We are asked to find the Riemann sum of the given function on the closed interval from 0 to 3 using left endpoints and 6 equally spaced intervals. Let's begin by denoting that n from our Riemann sum formula is equal to 6. And we proceed to calculate the width of each of the rectangles, delta x, which is defined to be b minus a divided by n, where b is the value of my right endpoint of the interval and a is the value of the left endpoint. Simplifying this expression yields 1/2. So now we know that each one of the equally spaced intervals is precisely 1/2 in length. Let's draw this so we see it in front of us. So now I have my 6 intervals, and I'm supposed to indicate the left endpoints. So my first interval from 0 to 0.5 has 0 as my left endpoint, while the second interval from 0.5 to 1 has 0.5 as the left interval, and so on for all of the other 4 intervals. Now it's a good idea to label these in a general way, so x1, x2, x3, x4, all the ways to x6, so that we see the overlap with the formulas. It's also a good idea to list these partition points, so the values. x1 is 0, x2 is 0.5, x3 is 1, and so on, all the ways to 2.5. Notice that these partition points are also spaced 0.5 distance apart. So my delta x shows up in more than one way. Before we proceed, let's have a look at the graph of the function so we can visualize these rectangles of the Riemann sum. For that, we can use any graphing calculator, as I have done using Desmos. Now let's zoom in so we see the grid points more clearly. Now we identify these left endpoints on the graph. So 0, 0.5, 1, 1.5, 2, 2.5. These are now the locations of our function values. And notice that the very first one gives us a function value of 0. So the height of this very first rectangle is 0. Hence, we do not get any area out of that rectangle. The second rectangle, however, does have height. If you want to call it height, it's actually negative. But we understand that we do get a function value that will create our rectangle. And we proceed for all of our partition points to find the function values. And then to complete them to our rectangles. Notice that these ones here sit outside of the function, and the last one actually gives us some positive area. So let's indicate this actually, that our first 5, well, this one doesn't have any area, so the next 4 have a negative value, and the last one has positive area. Let's notice that here we have a little bit too much area, likewise here, but then over on the other side we have a little bit too little. And it looks like that what we have too little and what we have too much is roughly equal in size. And then we have positive area missing. So this tells me that whatever we're calculating is going to give us an underestimate. We now proceed to calculate this Riemann sum. Since we are asked to find the Riemann sum using the left endpoints, we denote this by L, and because we need to use 6 equally spaced intervals, we use the subscript 6. So the width of all of our rectangles is delta x, and then we have to multiply that by the height of each one of these rectangles, which comes from f of x1, the next one from f of x2, and so on all the ways to f of x6. Then we substitute this with our partition points. So this is f at 0 plus f at 0.5 and so on. Let's just denote the last one, f at 2.5. And just to make sure we understand where this is coming from, let's actually indicate that this very first value refers to the height of my first rectangle, which happens to be 0. And the second one is this length right here, and so on until we hit the last one, whose height is given by this value. We also know that delta x is 0.5. And now we need to calculate the function value at each one of these partition points. And for that, I suggest we use a calculator. And in my case, I'm using the Desmos calculator. So here's my table of values. Notice that here are my partition points from 0 to 2.5, and here are my function values that I now have to add up. And that sum is going to yield negative 16.875. Multiplying this by 0.5 means I'm halving the value, so I get negative 8.4375. And with our discussion on too little and too much area, we note that this value must be an underestimate. Now we have found the Riemann sum of the given function on the closed interval from 0 to 3 using left endpoints and 6 equally spaced intervals.